Welcome to the 2021 ORSC Code Update Training. In this video, our technical team will be covering significant changes of the new iteration regarding general design, structural requirements, and fire and life safety. We appreciate you tuning in to the presentation and look forward to working through the updates with you. For this training, our general course goal is to provide a broad view of the administrative Chapter 1 changes in the 2021 ORSC. We'll talk a little bit about the background that led to these updates, and we'll cover some of the updates in specific detail. We also will identify the significant technical changes of the 21 ORSC regarding the structural, fire life safety, and general design requirements. As always, we welcome any and all inquiries regarding the technical content and have provided an email address for you to submit the inquiries to. Our team also plans to organize and offer a Q&A session in the near future to address submitted inquiries regarding the 21 ORSC significant changes. To ensure that you receive notification of that Q&A session, please be signed up for division updates. Here's a quick team introduction. First, I'm Tony Rocco, and I've been with the division since 2011. I'm the Structural Program Chief and have worked full-time in the construction industry since 2002. In addition to holding 12 certifications, I also have an extensive home library of codes dating back to the early 1900s. I think it's important to have a detailed understanding of historical code trajectory when considering current code application. Eric is our Senior Building Code Specialist and has a wealth of code experience from an extensive Oregon Fire Service career, national code body involvement, advisory board roles, and related activities. He's a great resource for all things fire life safety and is our resident fire systems expert. Somehow we were fortunate enough to snag Eric as he re-engaged in the code application and development world a little over 3 years ago. Our program engineer, Jeremy, comes from a private design industry background and has multiple years working in a large jurisdiction in Oregon as a plan review manager prior to his time at the division. Since arriving at the division in 2017, Jeremy has exponentially strengthened our approach regarding all structural design considerations of the state building code, as well as our interaction with design industry stakeholders. He's a great resource for all things structural design. Francisco is our team logistics lead and code specialist. His vast experience in major project management and oversight, QC, representation as an owner's rep, and special inspections offers a dynamic element to our team. He also assists the other division programs in significant system upgrades and is the editing magician behind this video presentation you are viewing. Mark Heiser and Kelly Thomas are our energy and mechanical systems experts. They are incredible resources for all things energy and mechanical, and we'll have more complete introductions in the energy and mechanical training video. As a reminder, our team is a technical resource for our local government partners and other customers. We are always happy to assist and always appreciate hearing from you. For this video, here's the general format. Model code revisions from the 2018 IRC are shown as red underline for additions in the model code and red strike through for Oregon model code deletions. Oregon amendments are shown as blue underline for additions and blue strike through for existing amendment deletions. Chapter 1, Administrative Updates, Scoping Language. The division has been working over the past several years to clarify and align the administrative provisions of the code. During this process, we have engaged OBOA, the advisory boards, and other interested stakeholders. The public rulemaking process also included related updates to the 2019 OSSC. The associated insert pages are available through our division webpage. A significant concept of these updates is the scoping policy and distinction between unoccupied structures and occupied buildings. The may and the shall statements of 455.020 determine the framework for this policy and approach. Reasonable safeguards for the occupants and users of occupied buildings apply statewide under the State Building Code. Deference to local policymakers regarding regulation of certain unoccupied structures provides flexibility and local regulatory options. These items are identified here in red text, such as fences, towers, ground-mounted photovoltaic systems, freestanding flagpoles, and landscape retaining walls. The scoping of Chapter 1 identifies these optional matters in detail. Where local policymakers choose to extend regulation to one or more of these matters locally, it would be reflected in the local process and related ordinance. It's important to note that both the shall and the may categories here fall under the division's regulatory scheme. While providing for local delineation in the may category, all work identified in either of the two ovals must comply with the respective construction standards of the State Building Code. Items outside both ovals do not fall under the authority delegated by the division. This includes dangerous building ordinances, local seismic rehabilitation programs, demolition, and participation in NFIP. As part of the Chapter 1 update, the scoping language has been revised. The ORSC governs detached 1- and 2-family dwellings and townhouses not more than 3 stories above grade plane in height and their accessory structures. The definition of townhouse is particularly vital when considering its application. Owner-occupied lodging houses with not more than 5 guest rooms. This use is also specifically covered by the exemptions from accessible design under public accommodations as defined in ORS 447. Residential aircraft hangars. And live-work units located in detached 1- and 2-family dwellings and townhouses where designed to meet Section 419 of the Oregon Structural Specialty Code. The following uses are required to comply with the OSSC and may not be constructed under the ORSC. Certified and registered child care facilities and foster care uses identified in Oregon Revised Statutes 418, 443, and 329A. When permitted by licensure to be located in a detached 1-family dwelling, these uses shall be considered Group R3 under the OSSC application. And congregate living facilities. These facilities would be assigned the occupancy classification they most nearly resemble based upon the proposed use. Congregate facilities may include various Group R or Group I divisions. Here's section R101.2.2, Optional Local Adoption. As covered on the 2 oval illustration, there are matters identified in the code that may be optionally regulated by a local municipality. Where local policymakers choose not to regulate the matters via local ordinance, they are considered to be exempt from building permit. This includes fences other than required swimming pool barriers, retaining walls unrelated to occupants of buildings, such as landscape retaining walls, freestanding radio towers, ground-mounted PV arrays, the construction of in-ground swimming pools, freestanding tanks, and fixed docks not supporting a structure. Where these are regulated by the local municipality, the construction standards of the State Building Code apply. The key concept here is that regulation of one or more of these unoccupied structures may be considered reasonable in an urban jurisdiction, but may not be reasonable in a rural area of our state. The intent is to provide local flexibility for addressing community-specific needs as determined by local policymakers and local elected officials. A significant change occurs in section R102.7 and the creation of new subsection R102.7.2 regarding repairs. This subsection is intended to align the ORSC more closely with the long-standing OSSC code path for the correction of damage for legally existing buildings. A critical consideration is that the owner of the ORSC governed structure, which was a victim of damage, will have a level of reasonable flexibility to consider when preparing to correct the damage. Within that reasonable flexibility, specific minimum safeguard elements are required to be included where necessary. The overarching key is that the repair activity cannot make the building any less conforming than the building was prior to the repair activity being undertaken. Standard and routine repairs, which are exempt from permit, are appropriately covered by section R105.2.2 and are not contemplated by this section. This section covers those repair activities which would require building permits and involvement by the local jurisdiction. Repairs for the purposes of correcting damage shall be permitted to conform to the code in effect at the time of original construction where the requirements of this subsection are met. The subsection then lists requirements from current code to be included in the repair activity as applicable. The 8 items listed must be considered in the damage correction. Repair to replace structural elements must comply with the loading and design criteria set forth in Chapter 3, or to the maximum extent practical as further approved by the building official. Smoke alarms in accordance with Section R314, CO alarms in accordance with Section R315, guards and window fall protection in accordance with R312, hazardous glazing locations in accordance with R308, emergency escape and rescue openings in accordance with R310, energy compliance via the existing Chapter 11 path, and floodplain construction requirements where determined by the floodplain administrator. Where one or more of these items is not in play based on the proposed work of the repair, it is not required to be provided in the damage correction. Such repairs are not required to conform to other new construction requirements. Where unsafe conditions existed prior to the damage occurring, the building official has the authority to make all determinations regarding correction of those unsafe conditions. The majority of significant repair and/or reconstruction of ORSC-governed structures may be guided by considerations well outside the state building code, such as insurance or desired homeowner modifications. Where modifications are planned by the owner, the compliance path for alterations would apply to all elements modified from the original legally existing design. The intent of this provision is to ensure that safeguards of current code are provided in the design while allowing for some design flexibility for those victims of damage. We've arrived at section R105.1 and a clarification brought about via public testimony from the City of Portland. First, note the strikeouts of items not governed by the ORSC: demolition, electrical, and plumbing. Next, let's look at the new language regarding the creation of spaces. The creation of new habitable spaces, new toilet rooms, or new bathrooms shall require a building permit. The long-standing statutory exemption of ORS 455.310 regarding non-bearing partitions and its inclusion in the list in section R105.2 of the ORSC has led to misapplication and customer delays. This new language is intended to clarify that when a new habitable space, toilet, or bathroom is created, a building permit is required to verify the design and dimensional requirements of the ORSC are met. This applies regardless of whether or not the non-bearing partitions qualify as exempt under section R105.2. Section R105.2 details work that is exempt from building permits. Based on the scoping policy alignment covered previously, the list in R105.2 has been adjusted accordingly. Clarifications have been added regarding reroofing and other items on the list, and I recommend taking a closer look at all of the updates to the subsection. On this slide, first we see the reoccurring language listed in the charging provision regarding the ability for municipalities to enact their own ordinances. This language occurs throughout the chapter as a reminder of broad local authority where not preempted by the provisions of the state building code. We also see a helpful pointer here back to the scoping language in R101 and those optional local adoption matters for unoccupied structures such as fences and landscape retaining walls. In the 2017 ORSC, Exemption 1, which is arguably the most popular exemption, was modified. This modification changed the height measurement to a wall height. Under this ORSC, the wall height measurement has been adjusted to more closely align with common land use limitations and with how we typically measure building height under the ORSC. This language also puts a limit on the overall structure height, whereas the wall height measurement did not. This measurement is now specified as a maximum of 15 feet from grade plane to the average height of the highest roof surface. Eric from our team created the following illustrations to show examples of this 15-foot maximum measurement. Notice that the measurement goes from grade plane to the average height of the highest roof surface. When dealing with a gambrel roof, notice that the consideration of the 60-degree angle and the definition of exterior wall is identified. Also remember that the application of this exemption only contemplates detached, non-habitable accessory uses. Section R106.1 details the requirements for submittal docs. This is a commonly misapplied section of code, and it ties back to the exempt structure considerations of governing statutes. First, in Oregon, construction documents are only required to be prepared by a registered design professional where their associated licensure laws specify. Any and all questions regarding architects and/or engineers' laws should be directed to OBAE or OSBILS, respectively. Exception number 2 has been clarified to align with the governing licensure and exempt structure laws of Oregon. Take a close look at Exception 2 and note the strikeout language. In Item 2.1, note the alignment with ORS 671.030 and the pointer back to statute. Item 2.2 is of significance in the context of the ORSC. Note that this exception is for a, quote, detached single-family dwelling or accessory building to a single-family dwelling. The key consideration here is that a licensed architect or engineer cannot be outright required by a local building official for those structures considered exempt, including a detached one-family dwelling or accessory buildings thereof. The last slide touching on this change outlines general information shared previously with local government partners regarding this understanding. You may want to take a moment here to pause the presentation so that you can read the language on the screen. Of note, while a local building department does not have the authority to overrule registered design professional licensure exemptions, they do have the authority to require any and all documentation necessary to ascertain code compliance during the plan review of construction documents. Where a design of a single-family residential dwelling is not entirely prescriptive, ORSC Section R301.1.3 may be cited to require a design in accordance with accepted engineering practice. This design would be required to the extent that the non-conventional elements of the design affect the conventional performance of the prescriptive design elements.
Section R301.1.3 Engineered Design. This Oregon amendment is intended to clarify whether an engineered design should be referencing the ORSC or the OSSC for the structural design criteria. This new language clarifies that the minimum live loads listed in Section R301.5, roof load provisions in Section R301.6, and deflection limits in Section R301.7 are to be used, and that all other structural design requirements necessary to complete the design shall be in accordance with Chapter 16 of the OSSC. For example, consider a multi-level exterior deck that falls outside the prescriptive limitations of Section R507. Although Table 1607.1 of the OSSC now requires a minimum of 60 pounds per square foot for residential decks, this amendment clarifies that the 40 pounds per square foot value from Table R301.5 of the ORSC would control as the minimum live load for the design. Table R 301.2, parenthetical 1, Climatic and Geographic Design Criteria. These changes to the Oregon amended table data and footnotes are part of a code-wide alignment of the ORSC's snow, wind, and seismic design criteria with the 2019 OSSC for risk category 2 structures. In the ground snow load column, the outdated elevation thresholds were removed, and Note A was updated accordingly to send the user to section R301.2.3.1 for site-specific ground snow load determination. In the design wind speed columns, the user is now provided tabularized wind speeds for each jurisdiction, which is the same as is provided in the 2019 OSSC for risk category 2 structures. And Note B sends the user to figure R301.2.1 to determine if the project site is in a special wind region. Note C for seismic design category removes the long-standing jurisdiction-specific seismic design category maps, instead aligning with the model code for site-specific seismic design category determination. A proposal was approved that changes Note E to include Multnomah County for an allowed reduction in frost line depth from 18 inches to 12 inches for project elevations below 2,500 feet. And lastly, the air freezing index values were added for use with and is referenced by Table R403.3, parenthetical 1, minimum footing depth and insulation requirements for frost-protected footings in heated buildings. Section R301.2.1, Wind Design Criteria. The Model Code Design wind speed terminology has been amended to align with the 2019 OSSC, and Model Code provisions for use by exterior component and cladding manufacturers and installers have been adopted. Note that this provision now only references Table R301.2, parenthetical 1, Climatic and Geographic Design Criteria, which provides the basic design wind speeds for each municipality in tabular format, instead of referencing the historic statewide wind speed map. Wall coverings, roof coverings, exterior windows, skylights, garage doors, and exterior doors all have minimum performance requirements throughout their respective sections of the code. The reference to Table R301.2.1, parenthetical 1, for tabularized component and cladding pressures is for use by manufacturers and installers to ensure compliance with each component's specific wind performance requirement within the code. Table R301.2.1, parenthetical 1, component and cladding loads for a building with a mean roof height of 30 feet located in exposure B. This newly adopted model code table provides the baseline component and cladding pressures for each zone identified in Figure R301.2.1, parenthetical 1. Note that the design wind speed terminology has been amended in this table for consistency, and the 140 miles per hour pressures have been replaced with 135 miles per hour pressures as an Oregon amendment for user convenience. For reference, the pressure zones identified in Figure R301.2.1, parenthetical 1, are based on prior versions of ASCE 7's component and cladding wind provisions. Depending on the actual mean roof height of a particular project and the actual wind exposure for the site, the component and cladding pressures from Table R301.2.1, parenthetical 1, are required by footnote C to be multiplied by the height and exposure adjustment coefficients from Table R301.2.1, parenthetical 2. Figure R301.2.1, Oregon Special Wind Regions. This figure is new to the ORSC and is referenced by footnote B of Table R301.2, parenthetical 1, Climatic and Geographic Design Criteria. Note that this figure is the same as Figure 1609.3 from the 2019 OSSC, which is based on ASCE 716. For project locations where it is not obvious from the figure whether it is inside or outside of a special wind region, Footnote A requires that it be verified using the ATC Hazards by Location tool, which is also the same tool referenced by the 2019 OSSC. Footnote B points the user back to Table R301.2 parenthetical 1 for wind speed determination and notes that the sites with full exposure to Pacific Ocean or Columbia River Gorge winds are identified in that respective table. Here are a few examples that showcase the changes to the basic design wind speed determination and associated verification of special wind regions. In Lane County, you see that the basic design wind speed is now 98 miles per hour for all areas outside the identified special wind region. This area and wind speed is shaded pink in this example. And the basic design wind speed within the identified special wind region is 120 miles per hour, which is shaded green in this example. See that footnote H further identifies that areas within that region along the Pacific coast having exposure category D shall use a basic design wind speed of 135 miles per hour. And note that both the 120 and 135 miles per hour wind speeds provided here are the same as the 2017 ORSC speeds for these areas of the county. Now let's look at a specific site address in Lane County that's near the transition between the pink shaded region and green shaded special wind region. The example address is at 10868 East Mapleton Road in Mapleton, Oregon. To verify whether this address is inside or outside of the special wind region, we access the ATC Hazards by Location tool using the listed web address from footnote A of the special wind region figure. Note that the user has the option of entering latitude and longitude or address. Once the address or coordinates are entered, select the Wind tab and click Search. Next, you'll see a dynamic map of the area on the right side of the screen and wind information provided on the left side with a note to select Dataset to view contours. Make sure you stay within the ASCE 716 dataset and scroll down to Risk Category 2 and select it. If a special wind region area exists in the dynamic map, it will appear as a shaded overlay, allowing you to verify whether the site is inside or outside of the special wind region. Now let's take a look at Multnomah County. You see that the basic design wind speed is now 98 miles per hour for all areas outside of the identified special wind regions, as shaded in pink. And the basic design wind speed inside the identified special wind regions is 120 miles per hour, which is shaded in green. See that footnote I further identifies that areas within that region along the Columbia River having exposure category D shall use a basic design wind speed of 135 miles per hour. And lastly, note that both the 120 and 135 miles per hour wind speeds provided here are the same as the 2017 ORSC speeds for these areas of the county. This last example for special wind regions is in Wasco County. You see that the basic design wind speed shaded in pink is now 99 miles per hour for all areas outside the identified special wind region. And the basic design wind speed within the identified special wind region is 110 miles per hour, which is shaded in green in this example. See that footnote J further identifies that areas within that region along the Columbia River having exposure category D shall use a basic design wind speed of 120 miles per hour. And note that both the 110 and 120 miles per hour wind speeds provided here are the same as the 2017 ORSC speeds for those areas of the county. Section R301.2.2, Determination of Seismic Design Category. This change replaces the outdated Oregon Seismic Design Category map with this latest model code figure. The model code figure has been amended to only include Oregon, and a note has been added to require sites on the perimeter of the identified seismic design categories to be verified using the Applied Technology Council's Hazards by Location tool. Note that this is the same tool that is now referenced in the code to verify special wind regions. As you can see, this is a significant change from our historical map, introducing seismic design categories B, D0, and E to areas of the state. But note that this change aligns the ORSC and OSSC for seismic design categories of Risk Category 2 structures. Note that this map will show seismic design categories in shades of gray in the ORSC, but is provided here in color for clarity. Let's look at an example showing how quick and simple it is to verify the site-specific seismic design category using the ATC Hazards by Location tool. Note that the user has the option of entering site-specific latitude and longitude or address. Once the address or coordinates are entered, simply select the Seismic tab and click Search. Per the note from Figure R301.2.2.1, we select ASE 716 as the reference document, select Risk Category 2, and select D Default as the site class. Then the reported SDS value is used with Table R301.2.2.1.1 to verify the site-specific seismic design category. Section R301.2.2.1.2, Alternative Determination of Seismic Design Category E. Although these provisions have remained unchanged from the 2017 ORSC, it's important to discuss here because they hadn't been applicable in the past, but now are in areas of Lincoln, Coos, and Curry counties, as seen in Figure R301.2.2.1. Remember that per section R301.2.2, it states that buildings in seismic design category E shall be designed to resist seismic loads in accordance with the building code, except where the seismic design category is reclassified to seismic design category D2 per this section. This provision gives two options for reclassification from seismic design category E to D2. The first option is to go through the OSSC path for site-specific seismic design category determination, and if it's found to be in seismic design category D via the OSSC, then it can be reclassified to D2 in the ORSC. The second option is to comply with the restricted construction outlined in subsections 2.1 through 2.3. This requires compliance with section R301.2.2.2.6 for being considered regular, with an additional stipulation that no cantilevers or offsets are allowed between stories, and that the exterior brace wall panels directly stack from foundation to the uppermost story without exception. Section R301.2.3.1 Ground Snow Load. This new subsection is a direct reference from footnote A of Table R301.2 parenthetical 1, Climatic and Geographic Design Criteria, and aligns the ORSC with the OSSC for site-specific ground snow load determination. This is the same procedure as outlined in Section 1608.2.2 of the 2019 OSSC, sending us directly to the online lookup tool and requiring adjustment to the reported value where required. Note that ground snow load is the only parameter used by the ORSC for prescriptive design, and Section R802.10.2.1, Applicability Limits for Engineered Wood Trusses, is the only reference to roof snow load in the ORSC. And that section states, quote, "For consistent loading of all truss types, roof snow load is to be computed as 0.7 times ground snow load," unquote. Note that 0.7 times 36 pounds per square foot ground snow load is equal to 25 pounds per square foot. The minimum snow loads listed are consistent with our historic minimums in Oregon and provide direct values to be used for prescriptively built homes utilizing lumber rafters or engineered wood trusses. The ground snow load adjustments from Table R301.2.3.1 are the same as those provided in Section 1608.2.2 of the 2019 OSSC, and are only required to be used when the actual project elevation is higher than the ground snow load elevation reported by the online lookup tool. Although there is no codified map identifying the extents of these 7 regions, a designer or code official could overlay a national or state-produced ecoregion map to confirm which region a specific project site is within. Here's an example ground snow and associated adjustment determination for a particular address in Newburgh. There are some areas of the state, usually near steep terrain, where the modeled elevation reported by the online lookup tool is substantially lower than the actual project elevation. Google Earth was used in this example to obtain latitude, longitude, and elevation for the project address. Note that the latitude and longitude parameters need to be in decimal degrees format for use with the online SnowLoad lookup tool. The latitude and longitude parameters in decimal degrees format are entered into the online lookup tool, and after clicking Get Snow Load, the resulting ground snow load and modeled elevation are provided. Note that for this example, the actual site elevation is higher than the modeled elevation, which means ground snow load adjustment is required. If the modeled elevation were greater than or equal to the actual site elevation, no adjustment would have been needed. Where it's not obvious which of the 7 regions from Table R 301.2.3.1 the project location is in, an ecoregion map, such as the one linked here, could be used to verify. In this example, an overlay with the ecoregion map shows the project site is within the Willamette Valley region. The adjusted ground snow load is obtained by adding the ground snow load reported by the online lookup tool to the product of the regional adjustment load multiplied by the difference between the actual and modeled elevations.
Section R302.1 has been updated to clarify several long-standing application questions, and our team is excited about these changes. First, minimum fire separation distances must be established independently where local land use laws permit more than one detached 1 or 2 family dwellings to be located on a single lot. A critical consideration here is that the term ADU is not a technical term recognized by the state building code. Where an additional detached structure meeting the definition of dwelling unit is permitted to be added to an existing lot, R302.1 will now address the application more directly. Next, we have a clarification regarding attached decks and consideration as a projection of the dwelling for the purposes of establishing fire separation distance or protected construction. And finally, a clarified minimum nominal thickness regarding the fire blocking footnote allowance of the table. Let's take a closer look at these changes. The charging language of section R302.1 now includes a new sentence. Where multiple detached dwellings are located on a single lot, each detached dwelling shall comply independently with table R302.1. The figure and the definition of fire separation distance may be helpful references here. Where these 2 detached dwellings are permitted on a single lot, our approach mimics the long-standing buildings on the same lot approach we are familiar with from the OSSC. We either assume an imaginary line between the structures to establish our minimum fire separation distance independently for each structure, or we provide fire resistance rated construction where required, which may be on one or both sides of that imaginary assumed line. Note the new exception to this charging language of R302.1 and the new definition of attached decks. The exemption clarifies that attached decks, which are exempt from building permits by section R105.2, are exempt from R302.1 and compliance with the associated table. All other attached decks are considered projections for compliance with table R302.1. The definition is reproduced from the OSSC and details this element as an exterior floor system supported on at least one side by the exterior wall of the adjoining structure and supported on the opposing side by posts, piers, or other support methods. Finally, the associated table is updated to reflect the following clarifications, both regarding projections. First, as you may recall in the 2017 ORSC, footnotes A and B were introduced. Footnote A permits omitting the tabular requirement of a fire resistance rated underside of an eave overhang when fire blocking is provided from the plate to the underside of the roof deck at the exterior wall plane. The clarification in blue is that the fire blocking shall consist of not less than 2 layers of 2-inch nominal lumber. Next, as we just covered in the exemption language on the previous slide, see the addition of footnote C in the projections row. This footnote clarifies that attached decks are to be treated as a projection for compliance with the table. Again, this would not apply to low decks which qualify for the permit exemption listed in R105.2, but does apply to all regulated attached decks.
Section R302.2.1 Townhouse Firewalls. This is an editorial change that's clarifying that under certain conditions, plumbing and mechanical are allowed within the cavity of a modified common 2-hour townhouse firewall. As you can see in item 2, the language indicates plumbing or mechanical equipment, ducts, or vents are not permitted in the cavity of a modified 2-hour wall. This language caused confusion, so for 2021, the underlined section is being added, except as specifically detailed in section R302.4.2.1. This pointer gets us to figure R302.4.2.1. This figure existed in the 2017 edition, we were just absent this pointer. The figure has also been updated for clarity for 2021. This only applies to modified common 2-hour townhouse firewalls. Section R302.2.3 Townhouse Utilities. This is an editorial change that's reintroducing the townhouse utility separation provisions. These provisions were originally included in the 2014 ORSC, along with a maintenance agreement that was required to be approved by the building official. The maintenance agreement was deemed to be outside of the scope of the statewide building code and was removed for the 2017 ORSC. Inadvertently, the utility language was also deleted. So for 2021, we're bringing back the utility separation language in section R302.2.3. What it does is it clarifies that any shared or common use utilities cannot run beneath any portion of the townhouse, and then further clarifies that each separate townhouse shall have its own utility services, and those utilities are not allowed to run through the attic of an adjacent townhouse or beneath an adjacent townhouse.
Here's one of the best changes in the 2021 ORSC, if you ask me. A big thanks to Jonathan Balkema and OBOA for their engagement on this one. We are in section R302.3, and we're talking 2-family dwellings. Historically, there has not been a codified path to address 2-family dwellings separated by a real property line. As 2-family dwellings are becoming more popular, many building officials have worked with customers to establish an allowable local alternate to address these configurations. Essentially what we have are 2 0-lot line dwellings with a minimum 1-hour ASTM E119 or UL 263 wall on each side of the property line. But the structural connection across the line was never directly addressed in the code. The new subsection R302.3.2 specifically addresses these scenarios, and it provides options for the customer to consider in the design. The dwelling unit separation of the 2-family dwelling is required to comply with one of the following. First, the townhouse separation provisions of R302.2 as applicable. As Eric just covered, these are 2-hour fire resistance rated separation requirements and are a perfect fit for this configuration. Next, 2 independent 1-hour walls. The customer retains the option to use 2 1-hour walls on either side of the property line as long as they meet ASTM E119 or UL 263. Or, as always, other methods of equivalent fire resistance as approved by the local building official.
Section R310.2.5 Emergency Escape and Rescue Openings Above a Lower Roof Surface. This is a new Oregon amendment for 2021 added by the Advisory Board. The intent is to keep a clear path open when there is a roof surface below an emergency escape and rescue opening. This would not apply to all windows with a roof surface below, only those that are EERO. The requirement is to provide a 36-inch wide path to the nearest edge of the lower roof. In the illustration shown, that path could go straight down, as indicated, or it could turn to the right if that edge of the roof is closer. The intent is to keep obstructions such as solar panels out of this area. Section R 310.2.6 Emergency Escape and Rescue Opening Replacement Windows. This is new model code language that exempts replacement windows from some of the EERO requirements where specific conditions are met. The exemption applies to the sill height requirement and the opening size requirement for new EEROs. In order to qualify for the exemption, the new window must be installed within the existing rough or framed opening, so no change in the framing is allowed. The new window must also provide an opening area that is equal to or larger than the existing window, and the new window's operating style must be the same as the existing window, or provide an equal or greater opening area. The new window cannot be part of a change of occupancy or use. You will note in item 2, or use, is underlined in blue. This was added as an Oregon amendment. This new language also aligns with the long-standing statewide code interpretation 92-01.
Section R311.7 includes a great clarifying change. Under the CABO code and the first few iterations of the IRC, it was clear that all stairways directly serving the dwelling were governed by the stairway provisions. Since the 2008 ORSC, this path has not been clear in code. New language has been added to clarify which stairways are governed by the provisions of R311.7 and which are not. Note the exception here. Stairways not within or directly serving a regulated building, patio, porch, or deck are not governed by the provisions. See the example image on the right. This stairway would not be regulated by the ORSC. The new language is intended to resolve a cited path for common deck stairs leading to a backyard, for example. See the image on the left. Under the 21 ORSC, these stairs are regulated. Under the ORSC from 2008 through 2017, only stairways that were an element of the required means of egress were citable. Here's a quick model deletion regarding alternating tread devices. I know a lot of you follow the model code process and language, and this is an important change to note when considering the application in Oregon. We're in section R311.711. The model code exception permitting alternating tread devices to be used as an element of the required means of egress was not adopted in Oregon. These devices may still be used as an accessing means in accordance with the charging language, but may not be used for prescriptive means of egress under the ORSC. Here's the companion provision to that which we just covered. This is subsection R311.712 and is regarding ship's ladders. Note the exception and the deletion of the model code allowance permitting these ladders to be used as an element of the required means of egress in certain scenarios. This is not adopted in Oregon and is not permitted under the 21 ORSC. As with alternating tread devices, these ladders may absolutely be used as an accessing means via the charging language of the existing provision. This existing charging language was first introduced into the 2017 iteration of the ORSC. While on the topic of ATDs and ladders, here's a quick revisit regarding the statutory compliance path for small homes. There's no code change here, just a quick revisit and hopefully a helpful reminder. In 2019, the Oregon legislature created a new statutory definition for small homes and outlined a streamlined local construction standard for these dwellings. As defined, a small home means a single-family residence that is not more than 400 square feet in size. Statute specified that the 2018 IRC, including but not limited to Appendix Q, be used for the design and construction of all small homes in Oregon. Additional details are reviewable at the link to the Enrolled House Bill 2423 from the 2019 session, and may also be reviewed by looking up Oregon Revised Statute 455.616. Here's a quick informal summary of the statutory path for small homes. Again, there's no code change here. This is just a helpful reminder. First, it establishes the unamended 2018 IRC, including Appendix Q where applicable, as the mandated construction standard for all small homes. It defines a small home and sets the size threshold, as we covered previously. It permits lofts for sleeping or habitable uses accessed by only an ATD or ladder. This is detailed in Appendix Q of the unamended IRC. It identifies that all small homes are to be protected by an automatic sprinkler system in accordance with the 2018 IRC. This would be an NFPA 13D system. It also provides design flexibility to be considered locally, and this is referring to building official discretion, authority, flexibility, and design trade-offs. It reinforces and restates the requirement for a two-head design. It also specifies the water meter service size and limits the maximum design flow for that two-head design. It outlines even more flexibility for a local building official to consider when reviewing small home proposals locally as necessary to meet those community-specific needs. And it only allows a small home to be used for residential dwelling purposes.
Section R312.2.1, Window Fall Protection. These new Oregon amendments are intended to clarify when window fall protection is required. Under the model code, the exterior measurement of 72 inches is from finished grade or other surface. Other has now been struck and replaced with flat. And this is to clarify that in configurations where there may be a roof below a window, but that roof is not flat, it would not qualify for exemption from window fall protection. The Second Amendment places a minimum width of not less than 36 inches to also qualify. So this would eliminate configurations like small eyebrow roofs or similar. If you look at the illustration on the left, you will see that the lower two windows have no requirement for fall protection. Even though the bottom of those windows may be more than 72 inches to the finished grade, they are less than 72 inches from the flat surface, which is the deck. The upper windows, assuming the bottom of those are more than 72 inches from the deck, would be required to have fall protection. The illustration on your right now shows those same two lower windows, but without the deck surface below. So assuming they're more than 72 inches above the finished grade and 24 inches above the floor on the interior, window fall protection would then be required.
From R312 all the way up to section R324 and solar energy systems. This new section details pointers for both solar thermal and PV systems and is a navigational provision in nature. As a reminder, since 2015, the provisions governing all roof-mounted PV arrays have been located in Chapter 31 of the OSSC. At that time, the governing advisory boards elected to incorporate the existing Oregon Solar Installation Specialty Code provisions into the OSSC and create reference from the ORSC for those ORSC-governed buildings. Under the 2017 ORSC, the pointer was located in Chapter 23. In the 2021 ORSC, the Chapter 23 pointer remains, and this additional navigational provision is added for clarity.
Section R326, Habitable Attics. These are new provisions added to the 2021 ORSC. However, the provisions in the concept are not new. They were originally added to the 2009 Model Code as a definition, but that definition was not adopted in Oregon. In 2018, the Model Code moved the provisions to Chapter 3. And then in 2021, the Model Code further refined the language as they discovered that the provisions were less restrictive than the IBC for Group R3 height. The provisions in R326 do require minimum dimensions for the habitable attic space, floor area, and ceiling height as per Chapter 3. And it also establishes a habitable attic as a story above grade as a baseline. There are 4 exceptions that allow the space not to be considered a story above grade. Those are max floor area of a third of the story below, or it can go up to a half with an NFPA 13D system. The occupiable space in the habitable attic has to have a roof assembly above, a ceiling assembly below, and knee walls, if applicable, on the sides. And the floor of the habitable attic cannot extend beyond the exterior walls of the story below. Where a habitable attic is above the third story, an NFPA 13D system is required in the structure, as this starts to exceed rescue capabilities from the exterior for the standard ladders that are carried by the fire service. There's also an associated definition in Chapter 2 for habitable attic, a finished or unfinished habitable space within an attic. Section R329, swimming pools. This section will be adjusted in a couple of different ways. The first of which is the scope is being adjusted, and the second is a new reference standard. The scope adjustment is being done in part to align with the Oregon Health Authority's private swimming pool definition, and now reads which are accessory to 4 or fewer dwelling units. Also, the old Appendix G will be rescinded, and that'll be replaced with a reference to the 2018 International Swimming Pool and Spa Code. Note that it indicates barriers for residential swimming pools. The design and construction of the pool itself will be discretionary for regulation by the local jurisdiction, but the barrier requirements will be mandatory statewide. One of the benefits of this reference to the national standard is it contains a barrier exemption for both swimming pools and spas and hot tubs. This exemption would eliminate the barrier requirements when an ASTM F 1346 lockable cover for spas and hot tubs and a powered cover for swimming pools is installed.
Table R403.1, minimum width of concrete, precast, or masonry footings. Although the Code Adoption Committee and Board sought to align with model code in most instances, this table was expanded into 3 code pages of tabular data built on assumptions that were widely criticized at the national level for the 2015 IRC adoption. Although that change was approved for the 2015 IRC, substantial updates to that were made for the 2018 IRC, which was further criticized based on what was described as avoidable complexity, increased limitations of use, inaccurate assumptions made, and inability to capture some common prescriptive applications. So the board recommended updating the 2017 ORSC table based on the last model code that used that form, which was the 2012 IRC. As you can see, there were no changes to the footing widths for conventional light frame 1-story and 2-story structures, but there was an increase to the footing width to the conventional light frame 3-story structures. And for the other categories, including brick veneer over light frame and or CMU or concrete walls, the 1-story footing width decreased, whereas the 2- and 3-story footing widths increased. Table R404.1.2, parenthetical 1, minimum horizontal reinforcement for concrete foundation walls. These Oregon amendments to the model code table were captured in the 2017 ORSC errata and carried into the 2021 ORSC. Note that section R404.1.3.2 is applicable to all foundation walls, including basement walls and stem walls, and references table R404.1.2 parenthetical 1 for minimum horizontal reinforcement. Minimum horizontal reinforcement requirements for stem walls in seismic design categories D0 through D2 are specifically provided in section R403.1.3.1, but a similar provision for stem walls in seismic design categories A through C doesn't exist. After consulting with senior ICC staff, they confirmed that the amended table R404.1.2 parenthetical 1 and associated figure R403.1 parenthetical 1 meets the intent of the model code for minimum horizontal reinforcement for stem walls in seismic design categories A through C.
Section R408.3 regarding unvented crawl spaces includes two changes. First, we have a model code addition recognizing dehumidification of the space as a potential design option in item number 2. The system requirement specified is 70 pint removal per day for each 1,000 square feet of unvented crawl. The big change here is an amendment clarification within the exception. One disconnect when the exception was first added is that an active or continuous mechanical radon mitigation system is a potential design option in Appendix F where approved by the building official. This new language simply opens up a potential design option for those customers desiring an unvented crawl design in a county subject to mandatory radon mitigating construction. The key here is the definition of approved and the requirement for site-specific local building official acceptance.
Section R507, decks. This change includes a reorganization at the model level, some new model level provisions, and an Oregon amendment. Most of the revisions to this section align with AWC's DCA 6. Some of the changes involve a beam table and beam provisions have been updated. The wood deck materials now requires a minimum of number 2 or better and pressure treated or naturally durable. That "and" is really important. They've added a fastener section and an associated table. They added some prescriptive footing provisions and some helpful figures. They brought the frost depth exemption for freestanding decks from Chapter 4, but be aware that Section R403.1.4 still applies, which requires a minimum of 12 inches below finished grade. They added 8x8 deck posts to the deck post table, and that was just added to accommodate 3-ply beams. If you try to notch a 6x6 for a 3-ply beam, you don't have enough meat left over. And finally, a new Oregon Section R507.10 for guards specific to decks was added. This was model language approved for the 2021 IRC. Most of it just refers back to R312 for general guard requirements, and it primarily just addresses the post attachments to the deck related to guards.
Section R602.9 in Chapter 6 has been a topic of regular inquiries over the past several ORSC iterations. Our technical team has engaged with ICC senior engineering staff on the topic at least a half a dozen times, and we've had many robust discussions with local code officials about, in particular, interior cripple walls and the requirement for sheathing. In the 2021 ORSC, I'm happy to report this issue is now entirely resolved by early adoption of a 2021 IRC code change. The best part is that this comes from our own Robert Rice and is such a great change. Thanks for this one, Robert. This resolution comes from the addition of a single term in the second paragraph of the provision. Exterior. A big impact with a single term. The images are intended to reinforce this change. The continuous sheathing potential does not apply to interior cripple or pony walls occurring within the continuous exterior perimeter foundation.
Section R602.10, wall bracing. Although there were no significant changes from the 2015 to the 2018 IRC, clarifying Oregon amendments were made to several subsections. The first clarifying amendment is in subsection R602.10.1.2, offsets along a brace wall line. The added language prohibits offsetting a brace wall line when all of its associated brace wall panels occur within a single line. Without the change, the code unintentionally allowed designers to essentially reduce the building footprint and associated diaphragm load going to the wall lines. The amended language was confirmed with senior ICC technical staff regarding model code intent for prescriptive wall bracing provisions. Another clarifying amendment was made in subsection R602.10.4.1, mixing methods. Item 2 of the model code has had and still has two separate and distinct provisions within that item. These were separated by moving the second provision to its own item number. So now item 2 is specific to mixing intermittent bracing methods from brace wall line to brace wall line within a story. And now item 3 captures mixing of intermittent and continuous sheathing methods from brace wall line to brace wall line within a story. All other items remain unchanged except for renumbering, such that there are now 6 items instead of 5 under this provision. This tabularized summary of this mixing methods section is provided here for quick reference. The last subsection we'll be discussing from section R602.10 wall bracing is section R602.10.4.4 panel joints. Note that the only changes to this section are its movement from section R602.10.10 to a subsection under section R602.10.4 construction methods for brace wall panels, the addition of model code clarifying language, and the original item 3 was reworked and moved to item 1. Note that this section captures all brace wall panels utilizing panel sheathing, including continuously sheathed methods. It's important to note that for a continuously sheathed structure, horizontal blocking is only required at the qualifying and/or designated brace wall panels. All other areas of the structure required to be continuously sheathed for that method, such as above and below window openings, etc., do not require the horizontal blocking. For this reason, it's important that the plans clearly identify the qualifying or designated CSWSP brace wall panel locations, such that the inspector is able to verify which portions actually require the horizontal blocking.
Here's section R905.16, PV shingles. Model code language is now introduced addressing PV roof shingles and other building integrated photovoltaic panels. This first subsection covers the PV shingles. As with other roof coverings, various code requirements are now specified in this new subsection for the installation. The major elements here are the pointers back to the electrical code and reference of the manufacturer's installation instructions. There is also a new definition in Chapter 2 for this product, a roof covering that resembles shingles that incorporates photovoltaic modules. Pretty straightforward. Section R905.17 now includes a similar construct for building integrated PV roof panels. Note the references here back to R324, the electrical code, and the general subsection reference to the manufacturer's installation instructions. An associated definition for this product also appears in Chapter 2 as well. Finally, a reminder for both BIPV and PV shingles is that now Chapter 1, Section R105.2 specifically excludes the installation of these products under the re-roof permit exemption, meaning if a customer wishes to add these products to an existing dwelling, a building permit is required statewide.
Section R908.3.1, Roof Recover. This is a fairly simple change. It rescinds the long-standing amendment in Oregon that allows 3 layers of roofing. So the language will now align with the Model IRC and the Model IBC, as well as many manufacturers' recommendations, which required a tear off when 2 or more layers were present already.
All right, so we've made it to Appendix F. Some great clarifying updates in this appendix. First, we regularly receive questions regarding the application, which is commonly misunderstood and misapplied. As such, the Advisory Board approved inserting language from the actual Senate bill into the code. Now under AF 103, the long-standing application is further clarified. Appendix F has always applied to new residential buildings. When considering the mandatory application, it is required for new construction of ORSC-governed dwellings. It is not required for additions to or alterations of an existing dwelling, garages, or moved buildings. Another great addition here are the revised illustrative figures. Note the pointer at the end of AF 103.1 to these 3 figures. Next, we have an amendment deletion in this appendix. The building tightness path, which was originally an Oregon Amendment option, has been deleted due to superseding requirements. In particular, the ACH 50 provision was out of alignment with the 2021 ORSC Chapter 11, and the duct language was problematic as well. This conflicting language has been removed, aligning us more closely with the model code language regarding radon mitigating construction. You'll hear more about the Chapter 11 requirements in the separate code update training video.
Appendix T, dwelling unit fire sprinklers. This change includes Appendix T being rescinded and replaced with a reference to NFPA 13D. NFPA 13D was historically an acceptable trade-off to Appendix T. Appendix T, as it was in the 2017 ORSC, was based on the Model IRC Section P2904. Oregon doesn't adopt the model plumbing provisions, so these provisions were placed in Appendix T previously. NFPA 13D has continued to evolve and now contains the same simplified prescriptive design methods that were found in P2904. So both options were no longer necessary. There's some examples of the simplified tables included in NFPA 13D to the right.
All right, so we've made it to the last technical slide on this part of the code update training. While not an actual ORSC change, this is a significant peripheral consideration to be aware of. Statewide alternate methods 13-01 and 97-01 will be rescinded as of October 1, 2021. In the near future, look for the associated docs to be updated on our webpage with a red line identifying the rescinded effective date. The lateral bracing SAM 13-01 has served its purpose as we bridged from the 2003 IRC to the 2009 IRC. As you recall, this method was loosely based on the 2003 IRC and is no longer deemed equivalent to current prescriptive lateral requirements. As such, the advisory board approved removing the option once the ORSC grace period had concluded. As a reminder, the grace period for the ORSC is 6 months this time around. This is reflected in the associated rule, and during this time, both the 2017 construction standards and the 2021 construction standards are acceptable options for the customer to choose. Many nationally recognized tools are readily available for those customers who have still not learned the current bracing methodology introduced in the 2011 ORSC. R60210 becomes further refined and clarified with each iteration and is a flexible prescriptive approach once folks become familiar with it. Similarly, the old 9701 portal is now superseded by multiple prescriptive portal options of the ORSC. Not to mention, there are many proprietary portal systems which have achieved code acceptance testing and reports. Outside of the prescriptive code, there are countless options for the customer to consider in their design. All right, look at that. We've made it to the end. Thank you for watching this code update presentation. We hope it was informative and enjoyable, and we appreciate you making it all the way through. Providing useful information to all of you in an efficient manner is important to our team. Hopefully we will be able to see all of you live at the next code updates. In the meantime, here are additional resources for you to consider. For our certified local government partners pursuing certification renewal, please be sure to review the details outlined on the certification renewal webpage. As always, for any cert renewal questions, we recommend you touch base with the training program experts, in particular Dana Fisher. Thanks again and have a great day.